Types of seismic waves. Seismic waves carry energy from an earthquake away from the focus, through the Earth's interior, and across the surface. Focus, point beneath the Earth's surface where the Earth moves. Focus, point beneath the Earth's surface where the Earth moves. Epicenter, the point on the surface directly above the focus. It is where the strength of the earthquake is strongest. Types of seismic waves. P waves are seismic waves that compress and expand the ground like an accordion. S waves are seismic waves that vibrate from side to side as well as up and down. Types of seismic waves. Surface waves move more slowly than P waves and S waves, but they produce the most severe ground movements. Seismic waves activity. Earthquakes and seismic waves. Seismic waves activity. through+Ea. Webcode, CFP 1022. http://www.thschool.com/webcodes10/index.cfm. Prefix equals CFP and suffix equals 1022 and area equals view and x equals 8 and y equals 7 ss. Types of stress, forces in Earth's crust. The stress force called tension pulls on the crust, stretching rock so that it becomes thinner in the middle. Types of stress, forces in Earth's crust. The stress force called compression squeezes rock until it folds or breaks. Types of stress, forces in Earth's crust. Stress that pushes a mass of rock in two opposite directions is called shearing. Kinds of faults, forces in Earth's crust. Tension in Earth's crust pulls rock apart, causing normal faults. Kinds of faults, forces in Earth's crust. A reverse fault has the same structure as a normal fault, but the blocks move in the opposite direction. Kinds of faults, forces in Earth's crust. In a strike-slip fault, the rocks on either side of the fault slip past each other sideways, with little up and down motion. Changing Earth's surface. Forces in Earth's crust. Changing Earth's surface. Over millions of years, the forces of plate movement can change a flat plane into landforms such as anticlines and synclines, folded mountains, fault block mountains, and plateaus. Changing Earth's surface. Forces in Earth's crust. Changing Earth's surface. Over millions of years, the forces of plate movement can change a flat plane into landforms such as anticlines and synclines, folded mountains, fault block mountains, and plateaus. Building vocabulary, forces in Earth's crust. A definition states the meaning of a word or phrase. As you read, write a definition of each key term in your own words. Key terms. Examples. Hanging wall. Footwall. Strike-slip fault. Anticline. Syncline. Plateau. Key terms. Examples. Stress. The block of rock that lies above a normal fault is called the hanging wall. Stress is a force that acts on rock to change its shape or volume. Tension. The stress force called tension pulls on the crust, stretching rock so that it becomes thinner in the middle. The rock that lies below is called the footwall. In a strike-slip fault, the rocks on either side of the fault slip past each other sideways, with little up or down motion. Compression. The stress force called compression squeezes rock until it folds or breaks. A fold in rock that bends upward into an arch is an anticline. Shearing. Stress that pushes a mass of rock in two opposite directions is called shearing. A fold in rock that bends downward to form a valley is a syncline. Normal fault. Tension in Earth's crust pulls rock apart, causing normal faults. Reverse fault. A plateau is a large area of flat land elevated high above sea level. A reverse fault has the same structure as a normal fault, but the blocks move in the opposite direction. Measuring earthquakes. Earthquakes and seismic waves. Measuring earthquakes. The Mercalli scale was developed to rate earthquakes according to the amount of damage at a given place. Richter scale. The Richter scale measures the size or strength of an earthquake. This scale is quantitative and based on the amount of energy released by an earthquake. The energy of a quake is a function of both the amplitude and the duration of a single wave. The seismogram below shows waves with a wide range of amplitude and duration. This would be magnitude 8 quake. Earthquakes and seismic waves. Seismic wave speeds, earthquakes and seismic waves. Seismographs at 5 observation stations recorded the arrival times of the P and S waves produced by an earthquake. These data are shown in the graph. Seismic wave speeds, earthquakes and seismic waves reading graphs. What variable is shown on the x-axis of the graph? The y-axis? X-axis distance from the epicenter, y-axis arrival time. Seismic wave speeds, earthquakes and seismic waves reading graphs. How long did it take the S waves to travel 2,000 kilometers? 7 minutes. Seismic wave speeds, earthquakes and seismic waves estimating. How long did it take the P waves to travel 2,000 kilometers? 4 minutes. Seismic wave speeds, earthquakes and seismic waves calculating. What is the difference in the arrival times of the P waves and the S waves at 2,000 kilometers? At 4,000 kilometers? 2,000 equals 3.5 minutes. 4,000 equals 4.5 minutes. Locating the epicenter. Earthquakes and seismic waves. Locating the epicenter. Geologists use seismic waves to locate an earthquake's epicenter. The modern seismograph. Monitoring earthquakes. The modern seismograph. Seismic waves cause the seismograph's drum to vibrate, but the suspended weight with the pen attached moves very little. Therefore, the pen stays in place and records the drum's vibrations. Instruments that monitor faults. Monitoring earthquakes. Instruments that monitor faults. In trying to predict earthquakes, geologists have developed instruments to measure changes in elevation, tilting of the land surface, and ground movements along faults. Using seismographic data. Monitoring earthquakes. Using seismographic data. The map shows the probability of a strong earthquake along the San Andreas Fault. A high % probability means that a quake is more likely to occur. Earthquake risk, earthquake safety. Geologists can determine earthquake risk by locating where faults are active and where past earthquakes have occurred. How earthquakes cause damage. Earthquake safety. How earthquakes cause damage. A tsunami spreads out from an earthquake's epicenter and speeds across the ocean. Designing safer buildings. Earthquake safety. Designing safer buildings. To reduce earthquake damage, new buildings must be made stronger and more flexible.